to share in our website. I think this is a good time to start. Good morning, everyone. Welcome to our symposium on additive manufacturing, and thank you for attending this collaborative event. I'm Mamullah Rudi, Principal Investigator for the DREAM project sponsored by the National Science Foundation. We are bringing people from the national and international organizations, successful 3D printing companies, additive manufacturing community, our regional industries, and local high schools to get to know each other and open up opportunities for collaboration in this ever-changing field. Our main theme for today's event is affordable additive manufacturing. The big question is this: how we can make additive manufacturing more affordable? The answer for this question has different aspects. Digital solution could be one approach. Using digital transformation technologies and reducing the connectivity costs would be one possible way. Combining 3D printing technology with other technologies like 3D scanning and CNC machining is an active trend to make additive manufacturing more cost-effective manufacturing solution. So at here, let me share my screen, and then presentation will be more meaningful. I was too excited and I forgot to share. Okay. Yes. Materials, print mechanisms, and the type of applications are playing crucial roles in this game. In our first symposium, Mr. Brian Conkle from Ashley Furniture generously shared his experience and his success stories on how they are using stereolithography technology for mass production. He registered for this event. Hopefully he will join, and we will listen to his comments, and if you have any questions, he might be interested in responding to that. Thanks to the National Science Foundation and ATE, Advanced Technological Education Program, supporting us to develop resources for enhancing additive manufacturing, establishing Fab Lab with cutting-edge 3D printers and 3D scanners, developing modules, hosting a website, and supporting our students and local innovators are outcomes of this project. The CVTC mission is to deliver innovative and applied education. Our dean, Dr. Jeff Sullivan, is a big fan of technological innovation. I guess that's why I can proudly talk about this topic at here. Innovation makes it possible to move and control robots on Mars, and innovation helped us to defeat coronavirus. And this series of symposia, we are trying to have a deeper understanding of a new innovative digital manufacturing process, namely 3D printing. Dr. Mike Lisecki, our external evaluator, supports us by his strategic ideas and detailed-oriented feedback. His evaluation broadens our project's impact quantitatively and qualitatively. CVTC is a data-driven institute, and in this event, we would like to follow our institute policy and share our simple statistical data with you. This graph that you see in my screen shows the number of attendees in our last symposia. We had a good jump in our last event from 15 to 23. I know our numbers are very small in comparison to other national events. The other graph that we have at here gives more detailed information about attendance of our passionate and enthusiastic high school teachers. We are working with our K-12 department to have more teachers in this event. Valuing diversity is one of our core abilities at CVTC. This graph is a success graph, increasing women participation from 7% in our second symposium to 26% in our third one. And at here, you see DREAM team members. We started with 3 members, and now we have 17 members at here. welcome to our new team member, Mr. Paul Garlamo from Manufacturing Engineering Department. Today's agenda, at here, Mr. Duncan Stewart, Director of Research for Deloitte Canada, will broaden our understanding of 3D printing and the future of this technology. After a 10 minutes break, we will have a panel discussion with precious members from academia, consultant organization, and big 3D printing community. In this panel, we will talk about different aspects of affordable additive manufacturing. After another short break, Kim Grady, an active member in ATE community, will demonstrate the performance of printing by pen. We will have a live demo, and if our print process fails, I think it would be a beautiful failure, and we will enjoy that because that's part of learning process. At the end of our symposium, our diligent high school teachers will present from their class. This will be another live event. We would see students' faces, their projects, and learn about how project-based learning works. When I think or talk about our high school teachers, I become emotional. I will try not to cry at here. Look at their faces. We meet every week with our teachers and share our educational experiences. Their passion for learning and teaching inspires me. Our high school students are lucky. They have wonderful teachers, hard worker, and optimist. Okay, now I think we can start our first session at here. Deloitte is a multinational professional service network with offices in over 150 countries and territories around the world. Mr. Stewart is the Director of Research for Deloitte Canada and co-author of TMT, Technology, Media, and Telecommunications series. Mr. Stewart will revisit his 2019 prediction on additive manufacturing, updated with actual 2020 numbers, and try to predict what comes next. He will also add a deep dive on how the educational sector needs to prepare for teaching the next generation of AM professionals. Duncan, since you are at here and you are our speaker, we have a couple of attendees from Canada, and it makes our symposium an international event. So welcome to our symposium, and I would like to say thank you for accepting our invitation, and we are excited to listen to your presentation.
Thanks very much. There's a bit of an echo on the line. There we go. So thanks very much for, sorry, somebody's got it on speakers and I'm getting feedback through. I'm not sure who that is.
Okay, what I can do, I can mute myself. Maybe that's me.
That might help. Testing, testing. That's much better. Thank you. There we go. Okay, now I'm going to request control and ask for the slides. I've done that. Request control, request. Okay, there we go. Okay. And now I'm going to try to share my slides. Here we go. And can everybody see that? Can somebody give me an audio confirmation that they can see my screen? Because when the disadvantage of Teams is I can't see.
Yes, sir.
Looks good. All right. Thanks very much. So hi, everybody. Welcome to my kitchen. You'll be disappointed to see that it doesn't have a 3D printer for printing out food, but I do mine the old-fashioned way. So let me give you a little bit of my history here. So hi, I'm Duncan. I'm Director of Research for TMT in Canada, but also globally I have a role. And Deloitte does this thing called TMT predictions. We've been doing it back since 2001, and we have written on 3D printing 3 different times over the years. I think once back in, I think it was about 2011, and again in 15, and then again in 19. And I've been updating the numbers, so although this slide here says 19, I'm going to kind of walk you through a little bit of my journey in terms of 3D printing. Now, what's my background in this area? First of all, I am a former investor and venture capitalist, public funds as well. So I got used to evaluating new technologies. And one of the really critical things, both at the venture capital level as well as public market level, is that there's a lot of forecasts out there for all kinds of industries, not just 3D printing, but there's a lot of forecasts. The joke in the money management and the asset management community is that when you are sitting in your office and people are coming in asking for money, every chart is up and to the right. And so one of the skills that you end up developing is an ability to fact check those numbers, to think about them skeptically and realistically. On the other hand, also to know when the slide, when the chart and the growth really is that good. Okay. So what I'm going to do is I'm going to kind of just bop through a few slides here, walking you through my 3D printing additive manufacturing journey. So first of all, I'm going to take you all the way back to 2011 or 12. This was back in the day when one of the really big concerns for the 3D printing impact on things like retailing and transportation, supply chain, and logistics. The idea back in the day, and some of you may not remember this, but 10 years ago, it was not uncommon to see stories out there that 3D printing was in fact going to replace retail and warehouses, and we would just print everything at home. And you may have seen this picture. This goes back an awful long way. One of the things that I did is I did a lot of my own testing. I had a bunch of friends who were 3D printing enthusiasts, and I asked them to send me pictures of what it was that they printed, and this was the kind of stuff that they produced. And most of you will be smiling right here. You've seen stuff like this, and you know that home 3D printers back in 2011, 2012 were no threat to IKEA. Nobody was going to be printing out their own furniture or any of that stuff anytime soon. They start using home printers. One of the things that I have found fascinating, by the way, is it is 10 years later, and the home 3D printing market remains extremely small, very hobbyist focused. Don't get me wrong, it's tremendous fun. Every single friend of mine who has done home 3D printing loves it, and they just thought it was the funnest thing ever, and they learned so much about manufacturing and design. It remains a wonderful entry point for people to learn about additive manufacturing and the processes. I'm not trying to make fun of it in any way, but I am pointing out that as a dollar value and dollar value of parts manufactured and so forth, it remains perhaps surprisingly niche even a decade later. One of the things, before I kind of get talking about the more serious one, this is a fairly old story. This is one I wrote about in my second 3D printing report. I always thought this was an amazing article. This was online, and you may have seen this back in the day. What was this, 6 years ago now? Somebody put out an article saying intricate 3D printed ice cubes. Wow, cool, amazing. And I thought about that a little, and I went, that's odd. I didn't know you could do 3D printing in ice. And I think the short answer is you basically can't. And what I did is I actually drilled down, and I found that this was not, in fact, a 3D printed ice cube. It was, in fact, a piece of ice that had been put in a CNC, a computer numerical controlled milling machine. And it was, in fact, subtractive manufacturing, not additive. But I always like this slide as an example. For whatever reason, maybe it's, the Star Trek, when Jean-Luc Picard goes up and says tea, Earl Grey, hot, and it just materializes there. We, as a society, have a fascination with 3D printing. We think it's a fascinating, amazing technology. And one of the problems with that is the media tends to treat it inaccurately at best. The PR value of sticking 3D printed on a thing that isn't even 3D printed is enormously high. It tends to draw a lot of clicks, a lot of traffic. And I want to kind of introduce this as a concept in there is so much incentive from a PR basis for companies to talk about 3D printing that it distorts, I think, the popular and even professional perception around the industry. Here's another one. This is from about the same time. Some of you may remember this. The space station, the ISS, had a 3D printer, and they made a wrench from a beamed up design. And if you can take a look at it, you can probably see that wrench there. It's small and it's plastic, and it actually wasn't functional. And of course, one wouldn't use it actually for anything because it wasn't strong enough. But I thought this was yet another example of that kind of PR thing, because of course, if you make a wrench, you tend to make them out of metal. And one of the problems, and most of you will know this, but the ISS is, I believe, a pure oxygen environment, and one would never use, for example, a sintering machine in space. It would be enormously hazardous from both combustion, but also vapor and so forth basis. So just another interesting example where the PR value of 3D printing or additive manufacturing kind of distorted. Because many people saw this, and this is in time for our prediction many years ago now, and many people asked me about this and said, "Oh wow, space station makes such a great example. It's at the end of a very long or difficult supply chain. It makes sense that they'd be able to 3D print stuff up there." And of course, the point was that this was just a test. Now, the test worked. A plastic 3D printer did work. The file did work, all that good kind of stuff. But at this point on the space station, they still have to bring most of their wrenches up into space, perhaps renewed by new flights from the Dragon capsule. One of the points now, most people on this call, I'm assuming, are experts in this space, so I don't want to spend too much time on this, but just a reminder, this is not my slide, this is a Deloitte slide that I stole. It's a really good one, I like it. It covers the waterfront. I will, Mahmoud, I'm happy to share a PDF of my slides, so you can easily steal all of my slides later, but that's just that one. I want to focus here on the ones in green. These are the ones that the four here that are perhaps the most interesting. This was something that I talked about when I wrote my prediction back in 2019. HP and others were coming onto the scene. It looked like a really interesting inflection point for 3D printing. Now, before I get to that, what exactly that inflection point was, I do want to make a point, and this is something that I never get tired about pointing out, is that although 3D printing is certainly, additive manufacturing is certainly exciting, back in 2019, I forecast sales of additive manufacturing as being on the order of 12 to 13% for the next few years. I'll show you that slide in a second. However, I did want to make the point that although that growth rate was certainly impressive, in terms of the dollar value of manufacturing technologies, 3D printing was a full order of magnitude smaller than CNC machines. Those are the numerical control machines I've already referred to with the ice cube. Now, they were growing more slowly, 6 to 7%, but nonetheless, $60–70 billion a year market. Still are, it's higher now, I think. And of course, when we compare that with traditional manufacturing, which is growing at more or less GDP, 2 to 3% a year, but once again is yet another more or less order of magnitude larger again. So as fun as it is to talk about 3D printing, it remains comparatively small in the world of manufacturing. This is just another slide that I stole from a colleague's deck, kind of looking through some of the advantages about additive manufacturing. Where does AM win? It's actually a bad slide here because you should actually have I just never realized this before. The scales should be heavier on the AM side. Anyway, where is AM advantaged? Small, highly complex, low production volumes. Great example when tooling is no longer available. That's always an interesting one. And of course, speed to market. That's very cool. And then where does traditional win? Parts at speed, low cost, high volume, diverse material selection, manufacturing standards. On balance, I like the sentence at the bottom. Additive and traditional manufacturing often exist together in the production environment. Really, really important. That's not going to change within the next, at least I would argue, 5 to 10 to 20 years. One part I did, this is once again the deck I've stolen, and I am getting to my 2019 forecast and then the update of it with real world data. Wanted to kind of talk a little bit here about some of the challenges. This is from an internal Deloitte report, but nonetheless, I think it's just a fabulous slide. Part size. We're obviously seeing some work being done there on the large size. That's where is that? That's down at Oak Ridge. I think is doing some fantastic work on some of those very, very large 3D printing projects. Speed getting better, but still terribly, terribly slow. The improvements in speed year over year are there, but I as far as I can see based on the literature I'm seeing, it remains significantly order 2, 3 or magnitude slower than traditional manufacturing. Things like injection molding and casting and so forth. Material limitations, multi-material. quality, consistency. I'm sure you know all of these. Nonetheless, it's worth remembering there are some limitations out there. Okay, that was a lot of prologue. Okay, here's Duncan. Here's your good friend Duncan. This was published in December of 2018. So the 2017 number was an actual. The 18 was done with the year well finished, not quite. So I believe I had Q1 to Q3 numbers. And what I was looking at here, and this is different. So some of you may be familiar with various industry forecasts out there about the size of the 3D printing market, and some of them, like you probably all know Wohlers, they are the total market, and they are a bit of a black box. It's not possible to really go through the data sets and be able to replicate them. So I did a different thing. What I did is I looked at the large public companies in the space. And what I did is one of the things that I really, as a former financial analyst, one of the things that I am a big fan of is large public companies, because they produce these things called audited financials. Now, I work at Deloitte, and I'm maybe a little biased, but I love audited financials. I find them transparent and reliable. Yes, sometimes they get restated, but at a very, very high level, large public companies are a wonderful data source as a fact check for really how big is this industry. So these were the revenues. Now, this includes a couple of companies who were large and public, but did not publicly disclose their 3D printing revenues, but for which we had estimates. I'll come back to that issue in a second. I'm not going to name them because I try not to name companies as much as possible. I'll explain why in a second. But nonetheless, you can see that although the 3D printing industry had been growing fairly slowly, this is the large public companies, in 2015 and 2016, at kind of 4 to 5% per year, 2017 was a pretty good year, and it looked like it was going to be pretty good going forward at kind of that 12 to 13% growth rate. Now, these were based not just on historicals, but these were based on analysts. So remember, I talked about the value of large public companies. Many of these companies have analysts following them, sometimes 5, sometimes 10, sometimes 15 or 20. And if you take the publicly available consensus analyst estimates for revenues, I was able to produce a chart that looked something like this, suggesting that 3D printing was a still relatively small industry, $2 to $3 billion from the large public players, but nonetheless growing at a significant multiple of GDP. Now, hype check, it wasn't growing at 50 or 100% a year, as some things do, but nonetheless, ain't nothing wrong with 12 to 13% growth rates, and I was pretty excited to publish that, okay? So I put this out, and everybody thought this was great, and it was all fabulous, and so, okay, I need to put my glasses on now. So I was asked by a colleague to take a look at, once again, the large public companies. Now, these numbers are not precisely comparable. The two large companies out there who are public but do not disclose 3D printing sales, and right now I'll say who they are GE and HP. And I excluded them because although I included them back in this estimate, I decided not to do that going forward. I said, I'm not going to do that because they're not audited financials. And if the whole point is I'm relying on audited financials, I shouldn't be including companies where I am relying on third-party estimates or guesses as to 3D printing. My understanding is that both for GE and HP, that they would not materially move the needle on the overall picture, but I can't confirm that because I don't have audited financials. So this is a list of what I believe are the 10 largest public 3D printing companies who disclose sales, 3D printed sales. So a couple of them are new. You may recognize Mark Forged in here, and Desktop Metal actually just went public last year, this year, through a SPAC. What does SPAC stand for again? I forgot. A special private acquisition company. So these are these blind pools of capital. You raise $1 billion or $2 billion, and then you go buy something else with it. So this includes both Mark Forged and Desktop Metal for the last few years. So let me kind of walk you through this. What I found interesting was that 2017 to 2018 kind of growth that I predicted did occur. So I looked for 12-ish% growth. The numbers don't match exactly, but they're certainly very, very close. You can see that, we saw some, and I'm not criticizing or praising any company, but you can see there was a jump in 3D Systems. Stratasys had kind of a less good year. On the other hand, Proto Labs had a big jump, as did Materialize. You can see here there's a lot of moving parts. And when you add them all up, there's a very solid, I think it turned out to be a 15% growth. So I was undershot. Interestingly, though, 2019, even pre-pandemic, no effect from the pandemic at all, my kind of let's hope there's 12 to 13% growth per year did not happen. We actually saw some underperformance across very nearly, certainly the big companies, but even the smaller ones, growth there was quite small, definitely under the sort of the 10 to 15% range one would hope. Not surprisingly, well, I'll talk about this in a second or two, but not surprisingly, we saw some relatively anemic growth in 2020. Market shrank, dropped back. In fact, the 3D printing industry in 2020, this is once again the 10 largest companies, actually saw revenues fall to under its 2017 level. It would in fact be, still higher than 2016, but it would be close. So really kind of an interesting story here. The idea that 3D printing, first of all, is a hyper-growth story growing at 50% a year is not true. The idea even that it can have sustainable 10 to 15% growth year in, year out was not true in 2019. Finally, one of the things that I want to draw attention to is back in February, March, in the extraordinarily early days of the pandemic, there was actually some speculation that the pandemic would lead to higher growth in 3D printing revenues for final parts manufacturing. As a result of the pandemic and as a result of supply chain and supply chain interruptions, we would actually see greater use of 3D printing for final parts manufacturing. That didn't happen. In fact, the slowdown in the auto industry and the slowdown in the electronics industry, both fairly significant consumers of 3D printing for prototypes, led to you can see nearly, I think it was 17-18% decline year over year. One thing I should mention right now is that it looks a little bit better for Q1. So we haven't got all the numbers out, but for Q1 of 2021, I have seen the reported numbers from 2 or 3 of the larger players. It's a bit difficult to tell because there's organic growth and then there's been some acquisitions and divestitures, but it's looking like compared to a relatively weak Q1 2020, it looks like Q1 2021 is bouncing a bit. I would say 5 to 10%. Q2 guidance is once again 5 to 10% growth. So I would absolutely expect to see these 10 companies have combined revenues of over $2 billion this year. But once again, it seems unlikely that it will crack this sort of $2.3, $2.4 billion level. One thing, and now I am a former fund manager, and I am not talking about stocks, okay? I am not recommending stocks. I am not suggesting anybody buy this stock or that stock, or this is a good one or that is a bad one. But one of the things is that as an analyst of the sector, the share price of the larger 3D printing companies tends to over time tell us something. This is a chart showing the performance over the last 5 years of our friends at Stratasys and 3D Systems. And as you can see, blue line is Stratasys, red line is 3D. As you can see, some kind of by and large, it reflects what we saw. Growth in 2018 was pretty good. Stocks kind of did well. They were up nicely. However, 2018, 2019, remember those numbers? I'll go back to them right here. Remember those numbers? 19 was weak, even pre-pandemic. You can kind of see that in the share price. These stocks were either flat with where they had been or even down from where they had been. And then, of course, as 2020, it became clear that 3D printing, additive manufacturing revenues were falling, at least in the first half of the year. You can see that both of them ended up being down fairly significantly from where they had been back in 2017. Now, a fascinating thing occurred, and I don't want to spend too much time on this, but I do want to mention it. a fascinating thing occurred in sort of just around January. Some of you may be familiar with the whole, they're called stonks. A whole bunch of young people got into the market. There's a company called GameStop, which saw its value rise massively, largely due to putting pressure on a short position. It happened with AMC movie theaters. It happened up here in Canada with our company, BlackBerry. Yes, it's still around. But fascinatingly, something weird happened with 3D printing stocks in the early part of this year. As you can see, our friends at 3D Systems just exploded up, doubling, tripling in value from where they were in 17, and I think 5 or 10 times from where they had been in their lows. It happened in Stratasys. As a matter of fact, when you look at almost any 3D printing stock in the early part of this year, there was an enormous boom. Now, what does this mean to me as somebody who tries thinking about the future of the industry? It's possible that this enthusiasm in the market for these stocks, you'll notice that our friends at 3D are still well up, even compared to where they were 5 years ago. Although they've given back some of the gains, they've kept some of them. A little different for Stratasys and some of the others, but nonetheless, is it possible that the stock market is telling us something and that the growth prospects for additive manufacturing are significantly higher than people would have believed until quite recently? Yes, that is possible. So that's something to keep in mind. The other thing, though, is that this whole GameStop thing is kind of seems to be a bit of a possibly not an indicator of future growth, but more an indicator that a lot of people out there have spare cash. This is true in both Canada and the United States. Americans and Canadians have saved between 9 and 11% of GDP sitting there in cash as a result of lower spending during the pandemic. Some of that is going out on stock markets, and some of it's going out on NFTs and Bitcoin and Dogecoin and all kinds of things like that. But it's also possible that this may not. So this could be a signal. This could be a signal of interesting times to come, or it's possible also that it could be a false signal that it's more about market enthusiasm. I did promise that I would spend a second talking about 3D in higher education. I'm not going to spend too much time on this. Why? Because there is an entire Deloitte Insights report, came out in 2020, that is stunningly good. It goes through it in enormous detail. The reason I'm talking about this is, one, there is this great report. Two, Mahmoud told me that you have high school teachers here, and obviously the educational angle is an interesting one. I think this is an important topic. I don't want to go into too much detail on this because, frankly, you're better off just reading the report. But I do want to highlight a couple of things from this. So this was written by my friend, Mark Cottelier. Mark's a PhD, and he's been writing about 3D printing, gosh, almost as long as I have. He works at Deloitte. Absolutely, I'd be happy to make an introduction if anybody out there needs to talk to him. However, he wrote this just great report. What are the needs? This was done in what we did is we talked to industry participants. So first point, multidisciplinary. It isn't just one thing. It is many things. It is, yes, it's about understanding plastics and metals and sintering and so forth, but it's also, and I think you know this, it's about design and engineering and so forth, specifically better design knowledge in terms of designing for additive manufacturing. They said that was a real need out there. Broader, more creative and innovative mindset. I mean, not to make fun of a Deloitte research paper, but don't we all want that? Anyway, that feels like a bit of a motherhood issue. Absolutely, a better understanding of AM's ties to existing manufacturing processes. You remember that slide I showed you, oh gosh, about 8 minutes ago. 3D printing, additive manufacturing, traditional manufacturing, AM plus TM work hand in hand. It isn't about either or, it's about both. I think that's an important part. Commercial mindset to understand the business case. I'm going to talk about that maybe later, but that one does matter. Ideal candidate. This one, I liked this slide. A lot of different parts. Now, once again, this all comes out in the full report. I would strongly recommend you use it. But this gives you a nice single picture. They are not looking for somebody who knows everything about additive manufacturing and nothing about anything else. It's absolutely looking for a multidisciplinary. I liked this. This is, I think, a very powerful slide. I hope if you haven't seen this before, please do. Download the Deloitte report. It absolutely kind of walks us through at the level of curriculum, facilities, research collaboration, and then goes left to right as we kind of walk up the experience curve, the maturity curve, and of course, requiring additional commitments of time, capital, and resources. So fairly obviously, you can start with a single lesson, a lab, maybe a 3D printer here or there. And then as you move further to the right, you can see how it gets much more complex, but also much, much more powerful. So did want to flag this. I think there's lots of fun there. I'm going to pause there. I think that's sort of more or less my official time. I'd like to throw it open for Q&A. I will say that this is just a slide I always put up there because it's got my contact info on it. Please do email me if you have any questions. But the other thing is people, especially in 2021, are saying, hey, Duncan, do you have a newsletter? And my answer is no, I don't have a newsletter. Don't have time. However, I do publish a lot of articles on additive manufacturing, but other topics as well on Twitter, LinkedIn, and Facebook. So on that note, I'm just going to say that slide is there. I am now going to, I hope, stop sharing my slides, and I'm going to stop sharing. And now I'm going to throw it open for Q&A on my part. By the way, after the break, I'm hanging around and I'm still part of the panel, but that was kind of a bit of an overview. So let me kind of close off here with some takeaways. Additive manufacturing, important industry, growing industry, matters for education. On the other hand, I think we have to be realistic about its growth prospects. When I look at the largest players in the space, the idea that we are nearing some, high double-digit growth rate, I absolutely see a bounce back in 2021 from 2020, from the low levels we saw during the pandemic. But longer term, if you ask me, how fast do I think the 3D printing industry, the additive manufacturing industry is going to be growing for the next 5 years? Where I used to say 12, 13, 14%, I think I'm an awful lot closer to 5, 6, 7. I have data. I have a long time series of large public companies, and although they are selling a lot of 3D printers for prototypes, and although they're selling a lot of 3D printers for dental implants and a lot of other applications, that tipping point where all of a sudden 3D printers are going to be used for large part manufacturing in volume, requiring thousands of printers and thousands of kilograms of materials, that tipping point has not occurred yet and does not appear to be imminent. There you go. Realistic point of view. You can certainly disagree, but I'll throw it back to Mahmoud for questions.
Thank you so much. Impressive. Like always, high quality. So we have one question from Dr. Lisecki. Mike, would you like to ask your question verbally, or you want me to just read your question?
I'm not leaving, Mahmoud. It's just I have a dog, and the dog needs to be let out. Don't go away.
Sure.
I will ask Mahmoud. We'll wait for the dog.
As everybody out there knows, when you have a dog, the right place, the right side of the door to be on is whichever side they're not on at present. So she does this 500 times a day. Hey, Mike.
Duncan, thank you for the presentation. You mentioned, one of the things you mentioned was materials, and in Mahmoud's Fab Lab, they have a metal printer. Is metal coming out of the GWiz stage? Is it coming out of the pilot stage? What do you think?
Oh gosh, yes, 100%. No, I would actually argue that in the 3D printing space, some of the highest growth I'm seeing is in metal. It is absolutely, plastic is great if you're doing a prototype and you want to stick something in a wind tunnel or see what it looks like. Metal is where the action is at for an awful lot of it. It is, if I had to, because I don't actually do this, but if I had to, I would say Mike, that's an interesting question. So when I said I'm taking my expectations down from 12, 13% for the industry as a whole to, let's say, 6, 7, metal would probably be closer to that double-digit rate, maybe even slightly higher. Plastics is big and important. Let's not make fun of plastics. However, it's acting as a little bit of an anchor, right? It's so big, but maybe growing a little more slowly, that it is perhaps obscuring to some extent the faster growth within the metal sector. Great question.
Thank you.
So great opportunity for sharing your questions.
I'm here.
While we're waiting, Mahmoud, if you don't mind, I'm going to follow up. So GE has shown a picture of like 50 machines light up, and then they're ready to do your high volume printing, and you're saying no, they're not. I'm exaggerating.
This call is being recorded, right? I am not saying no, they're not. When did GE show that picture, Mike?
Oh, it must be 2-3 years ago. I'm sorry, I don't really remember.
I
just
think you're
remember
right as well.
seeing that picture. Yeah.
So do I, and I may have even referenced it in one of my reports. So all I'm doing, Mike, is I am not criticizing a large and important Deloitte client. Let us be quite clear on that.
Okay.
However, our friends at GE announced October, November of 2020 that they were writing down their investment in their 3D printing acquisition I can't remember if they wrote it down completely or they just wrote it down by 90%.
I didn't know that. Yeah.
Yeah. You can do a search. Look, GE 3D printing, write down, just Google it, and there you go. Now, does that mean that they're leaving the business? No. Mike, I don't know. So I'm a CFA. I'm a chartered financial analyst. I've been doing this for 30 years. Holy cow, I can't believe I've been doing it that long. When companies do a write-down, that does not mean that they're exiting the business. It does not mean that business is unprofitable. It does not mean terrible things. But it also doesn't mean positive things. By and large, your accountants, whether they're Deloitte or somebody else, comes in and says, you see, you've got this $800 million asset on your books. Do you still believe it's worth 800 million? And if company management goes, actually, we think it's worth less than that, it's called impaired. And the valuation is impaired. When you write it down, it suggests at the very least that it isn't growing as rapidly as you thought it would be a few years ago. That's not the end of the world, and I'm not saying it is. It's GE is absolutely out there. I have seen lots of other stuff. Same with HP. I am just trying to suggest that in that chart where I showed the revenues from the various players, I don't believe the absence of those companies who are very large, multi-tens of billion-dollar companies. I don't believe that their 3D printing specific revenues would materially alter the shape of the chart I showed you in my slides.
Good. Thank you for the comment.
Steve, you look like you got a question.
Yeah, there's I've noticed I've been in the industry since 2004, so just a few years. Yeah. There's quite a few of those companies, and I was going to bring up too. HP was one of them. Actually, they've been in the market, and then they got out, and then they in, and then out, and then now they're back in again. So that seems to be a common thread, is they kind of jump in and out a little bit. And I think they come in and it's a new technology, or it was a new technology, and then they come out with a new way to do something, and then they kind of figure out, you know what, it's really a materials based thing that especially at least on the plastic side, which is our side, it struggles. Each one of them struggle a little bit. So
I don't want to use the word struggle. Once again, what part of loved and adored Deloitte client can I stress here? However, one of the things is, when I wrote my prediction in 2019, I had a view that new entrants, there was a whole bunch of new entrants. It's funny, it was maybe a simplistic view. There were new entrants who were good at selling machines. They had professional sales forces. They absolutely were smart and clever and well capitalized and vastly deeper pockets than the existing 3D printing additive manufacturing companies. Like an order of magnitude larger. Would it not make sense, Steve, that they would be able maybe to move the needle? Maybe some of the problem was that it wasn't the machines, it was the ability to sell the machine. So my wife, my loved and adored wife, used to work for Xerox, and the whole point about Xerox was they could sell. My wife once sold a very, very large and expensive photocopier to a monastery of Greek monks. I don't know how much they needed a photocopier, but gosh darn it, they ended up buying one from Barbara, which, if you've ever seen her, is not a surprise. My point is, in many industries, having the right financing plans, sales force, aftermarket support, integration with other things, sometimes that can transform an industry. we have seen large entrants over the last 3 or 4 years, and none of them seem to have done that step change. What was selling 2 billion is now 20 billion. It's interesting, the ability of companies to jam 3D printers down the client's throat through financing and sales and so forth doesn't seem to be there the way it was in some other markets.
Right, I agree, and I think also that the manufacturers are, and it's funny that you bring up Xerox because everybody has been waiting since 2004 for Xerox to announce they're getting into this industry too. And it's more of like what Xerox did, and when I go to the users groups, we all relate back to, what Xerox did for the printing industry is then they started, instead of selling these large machines and very expensive machines, give them away, but now they sell the consumable.
Right.
And so I think that's a little bit where this industry is going, at least from a manufacturing standpoint.
However, even though and also of course service bureaus, right? We're and Xerox supported that. I mean, at first they were all about selling you the actual printer and the consumable, but over time they had a whole printing as a service business as well, right? It was never that disruptive, but it was certainly part of their arsenal. We're seeing the same thing in 3D. That move of basically almost giving the printers away kind of thing, that also doesn't seem to be, at least yet, resulting in a significant expansion of the market, if I can put it that way. Not so far.
Right. And I think 3D Systems is the one that has done the most with coming out and competing basically with selling parts versus just machines and materials.
So. No comment. I'm trying to avoid talking about company specific that way. Any final questions before we have our break? I think it's only a minute or two until we're scheduled to all go off and get coffee or whatever it is.
Yes, absolutely. Our agenda shows that now time is for break, 10 minutes break, and come back at 10 a.m. Central Time. I think over there is 11 a.m. Yes?
11 a.m. for me. I'll go make a sandwich or something like that.
Okay, awesome. Enjoy your break. Okay. Now we have our panel discussion section at here. Thank you, Mr. Stewart, to be in our panel and shape our conversation today. Thank you, Ms. Kim Grady, to be in our panel and share your experience with us. Ms. Grady is expert in material and 3D printing world. Kim, you have collaborated with many 3D printing and material science experts, including my colleague Hans Michelson. And Mr. Eric Waldridge is a professor of additive manufacturing from Kentucky Community and Technical College System. He generously supports his partners and colleagues. I always learn and enjoy his posts on LinkedIn. I will share a link for his LinkedIn profile, and you will, if you visit his profile, you will face with an incredible additive manufacturer resource there. So we have designed 3 questions for you, for our panelists. After asking these questions, our valuable attendees may ask their questions verbally or by typing them in the chat area. So I'm going to ask my first question from Duncan, and I would appreciate if other members may share their opinion about the question as well. So Duncan, we often see media articles about breakthroughs in additive manufacturing, faster, better, cheaper, are new examples of end markets. Do you expect the market to see a seismic change in the near term, and how do you sort out the hype from the reality in terms of news flow?
Well, why don't I start out with the do I see any breakthroughs? That's not really super my area. I mean, I keep an eye on it. I have seen lots of stuff. I tend to be looking at it's driving by looking in the rearview mirror, but I tend to look at things like the billions of dollars of revenues from large public companies as an indicator of not just things that are possible on a bench or in a lab, but things that are actually hitting the market in size. And the advantage of that is it's very much grounded in reality. The disadvantage of that is there could absolutely be some breakthrough technology out there that I'm not seeing yet in the data, but that will transform the industry in a year or two. So I can't really go into too much detail on that, but I have some slides I wanted to share, and I'll do this quickly, but it was 2 funny stories that I talk about all the time. So I'm gonna share my slides yet again, and here we go. And I'm going to make it full screen, I hope. So not that one. So this is just an interesting thing that happened a few years ago. Is this the right slide? Yeah, so I thought I had another slide before this one. I must have cut and paste slightly. There was this is back in 2014. I know we've got some people here who've said they've been in the industry since 2004. I remember there was this thing, and it got picked up by media. You can't find the stories anymore for reasons I'll go into. But what I saw was this thing where they were talking about Delphi. I'm sure everybody here knows who Delphi is, saying that they currently used SLM for the manufacture of aluminum diesel pumps. And I thought this was fascinating. You can see the advantages here: part count, production costs, avoid post-processing steps. Wow, less prone to leakage. This is the greatest thing I've seen in my entire life. And I thought, it's Delphi. What I'll do is I'll go there and I will find out how many of these they are actually making every year. I mean, gosh, it's Delphi. It must be millions, right? And it was weird because I couldn't find anything on the Delphi website. So I wrote to Delphi and they said, we don't make this part. And I thought, that's kind of weird. And so what I ended up doing was, you see this picture here? This was actually a study, and if you look at all the endnotes, you can eventually figure this out. But if you actually drill down, this was a theoretical study. Somebody for the government, I can't remember who it was, National Energy Foundation or something like that, some government think tank, wrote a paper where what they did is they did a theoretical, if Delphi used SLM for manufacturing a part, it would look something like this, and it would have the following advantages. As far as I was able to tell, They never actually made this. This was picked up, and I did a search years ago. This is back in 2015 or 14. I did a search. There were literally over 100 news stories about how Delphi was using 3D printing to make this part. And as far as I've been able to find out, it actually never actually occurred. So that's kind of an example of go back and chase. Now, I want to give you a better example because I'm going to make fun of Deloitte here. So I am Deloitte. We are Deloitte. We love stuff. We put out a report called 3D Opportunity for End Use Process, and we actually talked about firms outside of aerospace using selective laser melting to produce burner components. Prior to the company's adoption, burners were manufactured in a bad way, and using AM, they were able to eliminate leakage, it weighed less, it improved circulation properties by 80%. Once again, I was like, wow, this is amazing. This is cool. And so I went on their website and I tried finding it out and so forth. This is a picture, by the way, of the burner they made. And I think we can all see why this might be intriguing from a 3D printing. I don't think you could cast this part. Machining it would be difficult. It looks to me at first glance like a really great use case for additive manufacturing. But I was having trouble sizing the market. So what I did is I actually had a friend in Belgium who knew the CEO of this company. And what we did is we had a little interview with him, not me, because it was done in Flemish, but he talked to the CEO. They only ever made, see the nice burners? They made 10 to 30 of those. They don't use them anymore. They actually found that there were problems, and now this is a while ago, so perhaps today it would be different, but back then they found that the 3D printing in high tolerance applications wasn't suitable. The post-processing, we all know this from 3D printing, so often the yes, it takes 2 hours to build or 4 hours to build, but then there's hours more of post-processing. It was also quite expensive. They also found that it wasn't flexible enough. The CEO, who, by the way, was an enormous 3D printing enthusiast, said the technology has a lot of potential but needs another 10 years. So the reason I talk about this one is it's yet another way of doing your fact checking on the hype is to actually go talk to the companies. Did you do this? Because remember I talked about the PR value in the news articles? The media loves 3D printing, and that's great. But when you see a story like this, do a bit of follow-up. How many do you make? How did it work? Are you still using it today? Are incredibly useful ways of sorting out pilots and prototypes and, gee, let's see if this works, from actually making it in hundreds or thousands of units year after year. So a bit of a long answer, but I did want to share that because those are real world stories of a couple of cases where I did some myth busting, if I can use that phrase.
Perfect. Eric, you are in an academic institute, and how do you see this world from that perspective?
We see additive manufacturing, and we say this pretty often. 3D printing additive manufacturing is not about the printer. It's not about the actual equipment. It's about the mentality. And our logic is, first of all, especially in terms of what we consider low-cost additive manufacturing, the ability to produce some in-use parts potentially with equipment that costs less than $1,000. What we see is happening is that particular level of equipment is getting smarter and better every 2 or 3 months, maybe even 6 months. We're seeing new versions come out. And so what we're saying to folks and getting into this is that this is the educational opportunity of a lifetime, because it is barrier removal of a thought becoming reality for basically no cost, no realistic cost. It is a barrier removal for someone to go out and start a small business. So in the earlier days, we did kind of focus on your major companies, trying to get students working with companies and get them into additive that were big. We kind of stepped away from that because we now see the real benefit is the grassroots mom and pop operations. That one person that says, hey, I'm taking this class, I'm learning additive manufacturing. and I have this idea. And now there's these platforms called Etsy and eBay and Facebook Marketplace, where a person can literally go out and create their own business overnight. Now, is the quality of their product as high end as injection molding? No. But the question is, does the customer care? Also no. And it allows us to get the ball rolling. So not only can we use this technology in education just to get people thinking innovatively, but we can also help fund and basically create startups with a price tag that's less than $1,000, sometimes under $600. The problem we have in education is that 3D printing is not being used for what it's really made for. And I make the comment pretty often, it's like there's too many keychains and trinkets being produced. I can take the same piece of equipment that I can buy for $450 off Amazon, and I can have it produce some keychains to be cool and fun, or I can turn around and have it print in carbon fiber and replace actual products that people can't get anymore. And it's the same machine, it depends on how you use it. So within education, here we have this great opportunity to start producing these high-level products, but the problem is getting that mentality, because additive does take a completely different way of thinking. So in education, there's tremendous opportunity, and that's one of the things that we are actually focused on right now, is that we managed to establish it at our side, but we're actually responsible for the entire state now. So our overall goal is to move the entire state workforce into an additive mentality, because the equipment's there. You know, as it's as good as we need it to be to hit this point, and the cost and the price tag is so low, why wouldn't we do this? The catch is, though, it's the mentality, and that's really the uphill battle. It's not about the printer, it's about the mentality. But it's limitless in terms of its applications, both in biomedical applications, surgical technology, diagnostics, everything all the way over to culinary, and of course welding, machine tool. We can now 3D print in stainless steel with a $600 printer right in the middle of a classroom, no safety problems, and we've been able to do that for about a year and a half, and yet it's just now starting to catch on. So we're actually pushing that out as hard as we can too, because that represents a completely new change of mentality too. So a lot of opportunities.
It is interesting to see different aspects of one technology in our panel. From, you are working in different sectors, so we hear that, we listen and learn and understand more. So my next question is for Kim. Kim, how can we utilize affordable additive manufacturing to deliver quality education to our students and incumbent technicians and engineers?
So can you hear me?
Yeah.
Yes? Okay, good. I fixed my problem with sharing too. So when you sent me that question, I broke it down into its three parts. Affordable, number one, and number two, quality education, and number three, the people, right? Students, engineers, technicians. And I looked at it from a viewpoint of the quality education. I am an educator. I'm an instructional technologist. Raise your hand if you know what an instructional technologist does. I always ask that question because nobody knows what an instructional technologist does. But I work in the education side of advanced technology, and I'm lucky enough to have worked with a lot of gifted subject matter experts, we call them. So I have like just enough knowledge about materials and 3D and AM and stuff like that to be dangerous. But I help them write their curriculum. That's basically what I do. And I'm going to share more about that later today. But yeah, so if you look at quality education and what that means to additive, you've got to look at what you're doing to engage your students, what you're doing to make it relevant and things like that. I mean, you could get a student that walks into your classroom or into your business or whatever, and they say, hey, I want to take this AM class because I'm interested in it. Well, you got to figure out what really they're interested in. And I like what Eric was saying about it's not all about the equipment. It's about the mindset. You got to get into their mind and you got to figure out, okay, why are you interested in this subject and what might I be able to teach you about it? And then making it relevant in terms of how is this going to affect their lives? You know, in the case of a student, I hear stories all the time. In fact, I'm writing a case study right now with somebody, how taking a additive manufacturing class changed their life. It got them going down that engineering path, right? And so a technician or an engineer might walk up to you and say, hey, how can additive manufacturing fix this problem for me? I've got this tooling problem, or I've got this production problem. I got something, a customer asked me to make something. How can AM help me with that? So you have to bring that level of engagement and relevance first. And you don't need equipment to do that. You absolutely don't. You actually have to have the right mindset. You have to understand the different bits and pieces of additive manufacturing that you can bring to that individual. And then I think, Duncan, you mentioned some things about experiential learning and stuff like that. Experiential, action learning, whatever you want to call it, problem-based. I think we've all embraced those pedagogies, those strategies, and we've decided that's how we need to teach additive manufacturing. So if you want to deliver quality education, you need to figure out how you can do that with or without the equipment. There's a lot of things you can do paper-based. There's a lot of things you can do, you know, brain-based. Get them to use their brain to seek out answers. That's what additive is all about, right? You want them to find answers and find solutions. So you have to look at those things. I'm going to get into something else called competencies later, but you just need to understand that. You need to understand that there is a pedagogy, there's a good pedagogy, but also problem solving comes into AM a lot of the time. In fact, I don't believe that AM is perfect. I don't believe that anything we do in AM classroom or otherwise, that it has to be perfect. I think we can make mistakes, and the power in AM, what we do in the classroom or what we do with the equipment or whatever, is finding why we made that mistake. What was going on with the equipment, what was going on with my design, materials, you know, whatever was going on there. And then the other thing is failure. You're gonna run across failure. How do you help your students through that? And again, you know, you get back to breaking it down and understanding it doesn't have to be perfect. Failure is okay. What else could you do here that might help the student understand? And then the last thing is, Duncan, you mentioned multidisciplinary. There's also something called transdisciplinary. If you were to draw a picture of multidisciplinary, you'd have a big circle labeled additive manufacturing with a bunch of little circles inside of it that has all those other disciplines, right? But if you look at a picture of transdisciplinary, you're looking at a bunch of concentric circles, and there's overlap, and there's things in math, there's things in engineering, there's things in shop class, there's things in this concentric circle area that you can grab onto into your additive manufacturing. A personal story, I worked a few years ago in getting technology and things like that into programs, right? So a school says, I want to develop XYZ program, and automation robotics used to be called mechatronics. And a lot of them failed because they didn't integrate all of those different disciplines into it. And right now I'm working with somebody who's creating an additive manufacturing curriculum, and I don't know if he's going to get it into the program or not, but he said to me one day, where's the math in additive? And I'm like, are you kidding me? Where's the math? And I said, there's, you know, at the time I was developing a visualization module. And I said, there's coordinates, there's computations, there's all kinds of things that you do when you're doing additive manufacturing. You just don't realize it. And I suggested to him, go talk to a math teacher. And he goes, oh, that's a good idea, you know? So if you open yourself up to the other academics and you work with them, talk to them, and find out, you know, what's going on, with them, you'll be able to make that connection. You'll be able to make it for yourself, and you'll be able to make it for your students. And I guess, the last thing is, the other last thing is, you don't have to do everything on fancy equipment. I'm going to be using this little 3D pen later on. And, a lot of things can be paper-based. There's all kinds of things you can do. I'm kind of the queen of what we call kitchen science. There's a lot of my faculty who don't have, this equipment. They don't have the ability to purchase it or whatever. And I always find solutions for them. How do you teach magnetic composites, for example, which I just did a course on, without all the equipment? You got to think out of the box that way. And so that's kind of my specialty. But yeah, I agree with everything that Duncan and Eric said too. So did I answer the question?
Yes, absolutely. I'm just, if Duncan or Eric has any opinion about this concept, yes, please go ahead and share. This is a technical conversation. I have some questions, and I think our attendees may have questions. One little question I have at here is, so we are talking about education. Chippewa Valley Technical College is a technical college. Eric is coming from technical college, yes, joining at here. Do we need to differentiate our educational modules for university students and for tech college students? Is there difference or not?
I'll jump in on that one. That's a really interesting question. One of the advantages we have specifically is that our system is both associates and technical. So it's technical and community college. One of the great things that we have to work with is every student, no matter what program they're in, they have to have a digital literacy course or approved digital literacy. So what we did is that we made our intro to additive manufacturing also comply with digital literacy, so that it's a course that anyone in any program can take, whether they're going for an associate's in English or an associate's in science, if they're going for culinary, biomedical, everyone can take this. Because we are going to teach them not only the proper use of technology in a professional work setting, your Word, your PowerPoint, your Excel, your cloud, your transfers, but all the while we're going to teach additive with that. So if we're going to write a paper or do some research, we're going to do it on additive. If we're going to set up an Excel form, we're going to do it on some additive tests or maybe some pricing, how to actually set up a billing Excel form. If we're going to do a PowerPoint, we're going to do a PowerPoint on how I'm going to pitch an idea to investors to get my project off the ground. So we built this class uniquely for everyone, so that even if you're going for a math degree, you will have an understanding of how the world works on the professional side, and you're going to have an additive skill built into it that you're going to get to take with you into the profession that you choose to be in, making it a very holistic approach. And the other thing too that we really like, as Kim was saying, we don't even have to have the printer. Actually, even our intro class, they spend most of the class, well, we'll say 60% before they're ready to do the slicing to actually produce a product. And then we introduce what printers we recommend for their own personal use at the end of the course, and they can go on to take another higher course. But the key thing is that once we do have them going into printing, or maybe they're taking the next level course, they're getting a printer on their own, we want them to print as much as possible. Because, years ago when equipment cost $200,000, the very first thing the teacher wanted to do was not let the students touch it, because if you broke that thing, it was down and it was a lot of money to get fixed. Now, $400, $300, that kind of price tag, we want them to break the printer, we want them to fix the printer, we want them to print as much as humanly possible, and most importantly, and this is the big ticket item that we see with the technology right now, we want them to learn how to upgrade the printer. We want them to go in and say, all right, I'm going to go in and update the firmware. I'm going to go in and change one or two little items that allows it to self-level. I'm going to go buy a $60 kit off of some website that has 3D printed parts that's going to update my printer so now it is an automated printer or can be repeated. We're going to add a Pi to it. We want them to basically see this machine as something that they can, trick out as much as they want. And here are the skills to get there. So it's mechatronics, it's coding, it's hardware, it's screws, it's nuts and bolts, and it's still for a price tag of under $500 total. And there's very few educational kits that have this kind of power that we could teach so much with. And if it breaks, they can fix it. That's the other great part about it too. So we have a mentality of like, this technology can be used by everybody. Our ag science students, absolutely. I live on a farm, I raise cattle. You better believe I 3D print stuff all the time for my farm. We want it, we've got a material that's actually made out of soybeans now. We have a material that is completely biodegradable. We are printing seed holders to basically improve the growth cycle of plants that you can print. It's for everyone. It really, really is. And so we just want to make sure everyone understands that and has that opportunity. And then, like I said, can upgrade and make them even better off that initial investment.
That I'll chime in. That's very cool, first of all. But we developed kind of a concept of infusion. If you want people to be exposed to additive manufacturing, but you're not teaching an additive manufacturing course per se, you can infuse some of the topics into your math or your engineering or whatever. And that has proven to be a lot more effective than having a standalone AM class. Go ahead and do that if you want to. Maybe that's going to become more of the mainstream. But I think the whole concept of getting these topics in AM into the other classrooms and things like that is going to get you down the road a lot further. And then if you happen to have a maker space or, printer space or whatever, fine. Invite the art class in someday, have the art class come in and sit down and see something get printed. Have them bring their idea to fruition if you can, But that's the sort of thing that I'm seeing it being a lot more successful.
Your responses were comprehensive enough to answer our questions in the chat area. So if you'd like to add more to that, we can do that. One little things I would like to add at here is we use Deloitte's articles and videos in our classes for educational purposes. So that's an educational piece from that institute. I think I'm going to go and ask my third question from Eric. This is, again, other panelists would appreciate if you share your ideas as well. So Eric, how can we combine 3D printing technology with other manufacturing processes to provide affordable additive manufacturing?
I love this question as it proposed because it definitely ties into one of the spin-offs that we are doing right now. And that is low-cost metal additive manufacturing. And it goes back to us, we take a $400 printer and we do about $200 of upgrades to it. And we use some of the bound metal applications such as BASF's producing, Virtual Foundry, and we're using those printers to print off green parts that will be sintered and become fully sintered and fully metal additive parts. And the process, it's not as good as SLM. There's shrinkage, there's other issues, but let's just face it, I've got a metal 3D printer now in my classroom for $600. And we already have taken those parts and we've done everything from machine tooling them. We've actually bored and tapped. We've actually ground them down. We've done surfacing. And most importantly, we have welded them. And so right now, what we're doing with the National Science Foundation funding and other fundings is that we are actually putting in metal 3D printers all across the state. We want them in small businesses. We want them in classrooms. And the goal of having so many out there is to get people producing this so we can get the data to dial it in, cloud sourcing this new technology so that it is innovated and iterated even faster. And something's not been done before, but we realize this is where it needs to be to make things better. It's the same thing with the app and the smartphone. Once we had the smartphone, people could become app makers. And then lots of people became app makers. And then people learned from other app makers. And so now we have really high-end and very powerful apps because of that platform being accessible. So we love conventional manufacturing applications combined with additive. You know, I want these parts to be produced, sintered, which is a conventional process, annealing, which is a conventional process, and then turn around and I want to weld them together. You know, we actually are doing some of the welding on the stainless steel parts that we are printing, and the welds, it actually welds better than stock stainless steel. There's some really interesting properties that we are seeing with this. So there's different grades of stainless steel. Titanium is coming out next. Inconel is already out there, and all being done on desktop level printers. The catch is obviously the sintering process and the shrinkage, the dimensional tolerancing associated with this. But that's not a barrier. This is the problem at the moment. We're going to figure it out. In another couple of years, we're going to have it dialed in. So it won't be a problem. It's actually just a solution waiting to happen. The other application that you can look at is just simply, you know, doing mold making, basically using 3D printers to produce plastic injection molds for short-run production. Conventional, high-quality capability, and it speeds up. And most importantly, it lowers the iteration cost. That's the catch to all this. We all know this from our own history of manufacturing and even mechanical engineering. The more we can iterate, the faster and better the product. Additive allows us to iterate way faster and get it into production way faster and then make changes almost on the fly, which is an incredible way to do business and to improve technology. Now, let's not forget that we are getting closer and closer to embedding electrical components into additive produced parts. It's one of the NSF F-Score projects that the entire state of Kentucky is part of. It's basically 3D printing and complex electronics and putting them together so that we have built-in robots, built-in sensors, and potentially biodegradable drone technology is what we're shooting for with this. And so there's some conventional applications. You know, we're going to go buy these circuit boards, but we're going to embed them in the print and maybe print the circuitry within the object to collect data, to give feedback, and very conventional, but also now part of additive, and can still be done on an affordable, less than $800 piece of equipment. So right now it is a huge open-ended opportunity, but again, it takes that creative thought to say, you know what, I could actually do this. I could take this pie and I can stick it in a print. I just have to design around it so that the printer knows what to do. I have to program it so that I can hit the right stop point. It's going to give me a buzzer so I know when to do it, put it in, let it continue on, and then run power to it. It's all there. It's just a matter of really getting people's minds to imagine what they can do with it and then show them, okay, now that you got that idea, I'm going to show you how to actually do it. And we're going to do it on something that you can afford. And if you want to scale up your company and do more of these, you just keep spending out $400 or $500 to buy more printers, and you keep scaling up. Again, we don't get too tore up about the fact that the tolerances aren't that great. We don't get too tore up about the fact that it doesn't look as perfect as a machine part. It doesn't look as perfect as an injection part, but functionality-wise, it looks just as cool. And so I saw an article, actually, it's like, why are we so caught up on that smoothness? You know, could this organic texturing be a better finish in of itself? And so a lot of that is built into the same process all the time. So yeah, those are kind of my thoughts.
Very good. We have
the only thing I would add, just for fun, to Eric's point, I've been fascinated for years about and I talked about it a little in my talk, the where you see AM and TM intersecting, the use of the two of them, and talking about molds and so forth. So I'm about to show off here. I don't know how well this is going to work. And everybody see my wedding ring here? Does anybody else out there have a 3D printed wedding ring? Well, neither do I, but the mold for my ring was in fact made with a 3D printer into which the gold was poured. So I hope I get some sort of special award for at least wearing, the only person here wearing a 3D printed object. At least 3D printing was part of the process.
Beautiful, beautiful and romantic.
Yeah, we're trying to do some casting now in our lab.
We have.
I'll cover a little bit about molds and the pen thing too. In fact, I'll cover a lot about what you guys have been talking about. You can teach this stuff without the equipment. It's fascinating once you start looking at it. So
we have a challenging question from industry member. So it's a Steve question. Steve, I can read your question, or if you like, you can verbally ask that. Either way could work.
Sure. One of the things I think that just to see is how you guys would advise to educate people on, and the students and also consumers, on product liability. Because that's a big thing. Just because we can make it, should we be making it? It's okay if we're talking about something that is not harmful, or I shouldn't say not harmful, but what if we're selling to mountain climbers and we're making carabiners? The tried and true, the traditional method of manufacturing has proven statistics and data that shows how solid a carabiner would be given a certain process. The additive side of it doesn't have that. So I'd be leery about using a carabiner if I was a mountain climber, going too high at least.
That's an excellent question, and we do build that in because, first of all, liability is in any field. You know, I design buildings also for a side company, so my whole world is liability. My whole world is proven codes that I can fall back on if something goes wrong. And so we do is, and typically folks that are going to that, they're going to go our next course, which actually deals with engineering analysis and actual finite element analysis on the products as best we can. We build in that understanding that, you know, if you're going to be looking at a part that is going to potentially hold up a human being or is going to be a life safety critical part, this is not something you should probably do alone. Now, if you're going to make a suction cup device that sits on the side of your shower wall so that you can hold a glass of wine, which surprisingly took off, amazingly, it became a product because of additive. It's a slightly different story. But we talk about the fact, it's one of the reasons we go into investment training, because we want them to understand that they need a team. Just because you have the idea, that's just the starting point. You're going to need funding, even in scaling up. You're going to need folks that understand this. And so part of the educational training is, how do I go pitch this to investors who can help me guide and understand those differences? And so there's a lot of that too. But at the same time, we also say, this is the time to strike. This is the time to just get the ball rolling. Because if we, and you all understand this too, students nowadays are easily afraid. And so if we start pushing too hard and go in the other direction of too much worry, they will back off. But if we give them the education of, this is possible, these are some things you can watch for depending on what you're doing. These are some of the tests that you can actually do with the exact software that we're teaching you how to design with. You can be moving that direction. And this is why you also carry liability insurance. And that's a real fact. Companies get sued all the time. Doesn't matter how great they are. Doesn't matter how wonderful the background of their expertise, how many tech trial runs they've done. They get sued all the time. It's going to be a fact of that matter. So whether the technology is additive or conventional, that's going to be a part of it. But the life safety factor typically going to require an engineering stamp on it anyway, at least in Kentucky for a manufactured project of that nature. And so we would push that too. So it's all built into the education because of that true awareness needs to be there. Give you a case in point. There's a company called Walleye Solutions. They are actually located about 40 miles from here. We actually did a USDA grant with them to get their company off the ground, and they make a product that is pretty innovative. Surprisingly, it solves the problem of having a lamp on a wall with no plug and having a plug on the other side of that wall. Instead of running an extension cable around or call an electrician, you can get a little 2-part part that they print and drill a little hole and screw from both sides, and it creates almost like a grommet through the wall, and it looks like it belongs there. Something that is a product they can sell and do quite well at, and yet doesn't have a major liability connotation to it. So those are the ones we typically focus on as those innovations. We generally don't have folks that are going to try to do mission critical parts as part of a new business startup kind of thing.
Yeah, that's a really interesting point of view and question. Teaching ethics and liability and stuff like that isn't something that may not be in the forefront of everybody's mind, but I just read a case study about a dad who 3D printed a prosthetic arm for his newborn baby. It's like, if you're going to jump into this, is it okay to jump in with something like that that's so life-changing, may not look great, maybe it doesn't work, it doesn't have all the bells and whistles and things that you want, and stuff like that. Is it okay to jump into this field and do it? Just do it, just to make a difference. And so that dad kind of exemplified that for me. And it was funny in the case study, the biggest aspect of that prosthetic arm was materials. It wasn't whether or not the joint worked exactly right or not, but it was it flexible and soft, and would this baby be okay with that kind of an arm? So all kinds of things come to mind when you think about this stuff. So.
And I think COVID also gave us a good demonstration of what happens when people just need stuff. In Kentucky, they basically did away with liability potential as a legal statute. If you were producing PPE because people needed it, you couldn't be sued. And because people needed it is what it boils down to. And this is one of the things that's really interesting. We take so much for granted. One of the interesting things that happened one time is that we talked about, we 3D printed a metal hinge and with using a low-cost printer. And we put it out on LinkedIn, and it was interesting. And people were like, this because it was a print in place. The hinge was never assembled. It just worked. And one of the common statements was well, we just go to the hardware store. Why would we need to do this? And I totally get that. We can go to a hardware store. There's a good chunk of the world that can't go to a hardware store. They don't have a hardware store. They're making hinges out of bark, and they're fixing their bikes with whatever they can find with reeds and just components. Imagine what happens when societies that don't have access to hardware stores suddenly could produce for themselves with low-cost applications and just a little bit of power. And so the fact is need sometimes is more important than liability, as COVID has clearly proven, and that society will move toward that need over that common way that we normally do things when the situation is dire enough. All right, and there's a lot of market out there for folks who aren't going to be concerned with how perfect your product is, and they're just going to want the need fulfilled.
I appreciate that, and I think you hit the nail right in the head initially when you started off with the PFEMA analysis. I mean, that's where I really think that that also needs to go along with the education on how to do these parts. But thank you for the input.
So we have time for questions. If there's any, we would be more than happy to hear and then respond. Our panelists know more about this. They're active in this world, And if you have any questions, please share.
I will go back. I think Hans had a question on the printer system, the reason for the low-cost metal. The current model is that we are taking the artillery sidewinders that can be purchased through Matterhackers and Amazon. We are taking those and upgrading their build plate and also the heat break and extruder nozzle. And we are generally using the BASF filament from Matterhackers to actually utilize to produce the metal parts. And that kind of, as far as printing with it, that's well established. The printer in question varies. We just use the sidewinders because they're very easy to upgrade, and they're very easy to assemble. So and pretty low cost model. Some other applications you can actually probably use the same thing with the enders can be modified to do it as well. The sidewinders are what we probably primarily use, the Sidewinder X1.
Perfect. I have one question. This is mainly for Duncan, but other panelists, if they like, they can. I would appreciate if they answer. So, what we hear is that the market size for digital transformation will hit $1 trillion in 2025. I don't know, is it correct or not? You may verify that. So if we consider different manufacturing processes as competitors, how AM could win in this competition to leverage that market size?
So first of all, the $1 trillion number is, I mean, I don't know, maybe it's 850 billion, maybe it's 1.15. I mean, at the end of the day, it's about that big. It is an absolutely enormous number. It is, in fact, larger than cloud computing. Not a lot, but kind of in that area. Growth rate, we are nearing. Do you follow baseball at all? A little? For those who follow baseball, you've probably heard the phrase of we're just in the first inning of whatever it is, meaning that it's so early in the process. In terms of digital transformation, we are, it's hard to tell. Are we 30% there, 40% there, 50% there, 60% there? But if you draw the classic S curve, we're on that sort of flattish portion as we are slow. We're not slow. We're really good growth right now. However, we are nearing the point where that S curve is going to start flattening off. When I say nearing, I mean within 5 years. We cannot keep up the growth rates on spending on digital transformation because at some point, everybody's transformed and then you stop spending on transforming that way. To that point, Mahmoud, to answer your question in a slightly different way, we at Deloitte, I am literally working with my colleagues on the question, what comes after digital transformation? Kind of, what's that next thing? However, to answer your question precisely, the concept of digital transformation, digital workflow, digital manufacturing, and remember that thing I talked about where we're combining conventional, traditional manufacturing with additive manufacturing, TM plus AM. There is a lot of interesting stuff being done. Some of it's been written at from Deloitte, where we talk about the tools needed to integrate additive manufacturing into your overall manufacturing processes. That is a non-trivial business that Deloitte actually does. So I have colleagues who this is one of the things we do. We talk specifically about how do we integrate AM into our overall workflows and things like digital twins and so forth. Now, I just think the way you asked the question of how does additive manufacturing win? I don't think it's about additive manufacturing winning. I think it's about having a digital process and workflow that includes additive as well as all the other parts of the manufacturing process. Does that help answer the question?
Absolutely, yes.
There is an article well, in my 2019 piece, I actually had an entire blue box about the need for digital workflow tools around additive manufacturing. So that's in the 2019 report, and it's still perfectly relevant today.
Okay, awesome. You know, your answer inspired me, kind of changed my vision. Don't compete, collaborate. Perfect. So if there's any question, please share. Otherwise, we are in our second break time. So 10 minutes break. And then after that, we will have Ms. Grady to demonstrate the print by pen. So dear panelists, on behalf of Chippewa Valley Technical College, I appreciate your support. Thank you so much for attending and sharing your ideas at here.
Thank you.
Thank you so much.
Very nice. Thank you.
Yeah, we appreciate it very much. And those questions were really good questions. You know, it's exciting to have this conversation in general, see where things are going. So thank you all for the opportunity.
Thank you.
Thanks.
Mahmoud, I got my issue worked out. So we're good to go.
Very good. Very good. Awesome.
Okay. See ya.
Okay. Our demonstration session at here. Ms. Grady, we are excited to see how print by pen works. Please go ahead and train us on how to use this affordable technology in our educational settings. You are on, I think. Yep.
Okay. Yeah, I'm here. So let me get, I think I can, where did it go? Oh no. I got to get to my slideshow.
Yes, I do see your slide at here.
You do?
Yep. Yeah.
There?
Yeah, disconnected. Now you not disconnection. No, you stop sharing. It was there. Maybe reshare again.
Okay. There we go.
Mm-hmm.
Go into slideshow.
I can see it.
Yeah. I am not used to Teams. Oh, here's view. Where is it? Okay, you can see it. There we go. You can see it now, right?
Absolutely.
Just the slide. Okay, good.
Yep.
Okay. All right.
Yeah.
So thank you for having me here to share with you a presentation on a workshop I've been developing for quite some time now, using the 3D pen tool to teach AM concepts. I told you a little bit about myself already, so I'm just going to skip over this. I do want to tell you, though, that this workshop is developed under a project called TEAM, Technician Education in Additive Manufacturing and Materials. And I've been working on this team for quite some time. We've developed quite a few modules. You can go to, it's actually part of the material science program at Edmonds Community College. You can go to team.org and get some of their materials there, or you can go to the materialseducation.org and get some materials there. So I just wanted to share that with you. One of the things that we did right off the bat on TEAM is we developed core competencies. If you're familiar with competencies, they're a way to design curriculum. You can use them to design curriculum. You can use them to assess. There's a bunch of things that you can use competencies for. So if you're lucky enough to have competencies available to you like these, I suggest you use them because it makes people like me, in faculty, it makes your job a lot easier. Also, I want to point out that the 3D pen has been considered kind of a crafty tool for a long time. If you go to the 3Doodler website is where you'll find a lot of information about the 3D pen that I'm going to be using today. There's a lot of crafty stuff going on. But what I've done with this workshop is I've actually created some real solid AM educational pieces, activities that you can use to teach these skills. So the standards that we have developed, there's 12 categories, 25 competencies, and 147 knowledge and skills. And the document actually looks like this down here. But what I did is I pulled out of our competencies, our competency model, it's called, I pulled out the ones that I'm going to go through today with a 3D pen. For real, we're going to learn how to apply concepts of angles and triangles. We're going to learn how to apply tolerances on component dimensions and specifications. We're going to do a lot with AM terminology. There's going to be a lot of stuff there. And then we're going to also create assembly drawings. We're going to perform advanced mating using multiple parts or sub-assemblies. I call it joining, not mating, but that's what we're going to do in this activity as well. And then I'm going to demonstrate some basic design principles that you can use in your classroom with this 3D pen. Okay? So what we did when we developed this workshop is we actually put together a kit for people to use. And in the kit, they were able to get a ruler. You'll see the ruler up here. Well, actually, they purchased that themselves. They got the spatula. They put these things together for themselves. We sent them out this template, which I'm going to go over. But these are the things that you need to do this workshop. And we're actually going to cover all of these activities, all of these topics. We're going to go over every single one of them. And I think you'll be surprised to see how much you can really, really do with the 3D pen. I'm going to do this in kind of a hybrid form. I have this presentation and I have a little bit of video and I have a little bit of hands-on. I actually have my mobile phone hooked up to show you down here on my desktop what I'm doing with a 3D pen. And I'm hoping this all works out. So we'll see how that goes. And then I want to point out down here at the bottom, my goal for doing this this workshop was to get the connected classroom activity together that you could do. You know, we mentioned pandemic. Everybody was, you know, wondering what can we do to keep the momentum going in our AM classes. So we wanted to do something for the connected classroom for instructors. So we created a 3D workshop using the pen. And to put this all together, I had to go through a lot of iterations. You know, you want to develop pieces of the things that you're going to make so that you can show them to people so that they can see where you're headed and what you're going to be doing. And it takes a long time, basically. You know, you really want to show people. It took me, I'm going to show you one of the products, one of the things that we're going to make. I'm going to show you how to make is a snowflake. It took me like 45 times to get the right design and the right piece together. So there's a lot to this workshop, and I hope you are going to be able to take some of this away with you. All right. So what was in the kit that we sent everybody was a 3D doodler pen, and it looks like this. Can everybody see that? Give me a verbal. Can everybody see it? I'm gonna turn on.
Yes. Yes.
Yes. I can see it.
Okay. So I just turned on, let's see, I just turned on my mobile phone. You can see it down here on the paper too, right? Yeah. So this is what the 3D pen looks like. It's got a lot of controls. You have a speed control, fast and slow. You have a heat control. The heat control is divided up into the different types of materials that you use. So you have one for ABS and one for PLA, which I'll talk about in a minute. So so you can set the heat. There's also a lot of adjustments you can make. You can adjust temperature here at this little port. You can also do some troubleshooting down here. There's little gears that the filament goes through down here. You can actually open up the window here and fix things if you need to. Yeah.
Just to be sure, we don't see your smartphone's camera at here.
You don't see it?
Yeah, not that one. In the previous setting, you shared both your smartphone and your PowerPoint, I think.
Okay, I might have to get out of here. Let's see. So I can see mine.
When you share, you can either share just an application or you can share a screen. You maybe are sharing just the PowerPoint program. If you change it to share one of your screens, maybe that would work. So if you stop sharing and then share a screen, then maybe we'd be able to see the whole thing.
Okay, maybe I just won't do that here. Then I'll do it. Can you see it in the camera? Can you see it in the computer camera? The pen.
Kim, since you are sharing your screen,
no,
that's why that's your hand and your phone. Yes, that's very small. But yes, now we see that.
Now you see it. Okay.
Yep. Very good.
So okay, so I'll go through the speed, fast and slow, the temperature settings, PLA or ABS, and then the adjustments here. And then troubleshooting, you can do some troubleshooting down here. And I have to tell you, when I've done this workshop virtually, if something catastrophic goes wrong, there's virtually, if you're in a virtual setting like I was, there's not a whole lot you can do, right? You're just pretty much going to have to go to a watch and learn kind of a situation if you're doing this virtually. Let's see. Let's go down here. So one of the things that I talk about in the workshop too is the filament. PLA, as you know, is a plastic, a thermoplastic, and that's what we use. I tend to stick to PLA. I don't use ABS a whole lot, and there's some reasons for that. And one of the reasons is it's a lot stronger. ABS tends to not be as strong. In fact, I've heard the saying that if you step on something made in PLA, you're going to regret it because it's really, really hard. But you can also see here that it's made from plant-based starch. A lot of people care about this stuff. They care that it's biodegradable, and it also has a lower melting temperature than ABS does. It's also possible to produce very detailed and intricate objects. And I like to show this picture. I took this at a mug event. You can get very, very detailed features with PLA. I didn't make these, they were just out on display. So if you look at this globe, those are pretty detailed features. And then if you look back here at the gears, those also have a lot of detail, and we'll go into gears a little bit more later. And then objects like this, it's pretty easy to make these things, even pretty much with a pen, but these were all made with a 3D printer, obviously. With the pen, you can't really do really precise objects like this. And I want to point out here, over here with the wrench, you see a little bit of, I guess this is actually called a pier. We're going to talk a lot about how you set things up on a platform, and a lot of times you might have to use a pier. But with the 3D pen, we call it a wireframe. Everything starts with a wireframe, and so you might have a little bit of excess material floating out here. That's true in the equipment that you use, and it's true with the pen. I'm going back and forth between my my applications here, so bear with me. So I'm going to, no, I'm not going to do that. I'll go to the next slide here. So this is how a 3D pen works. You can show this to your students. You can explain that both the pen and the printer has filament. A lot of times the filament on the equipment I'm showing here with my cursor is on a roll. The filament on the pen comes in a port at the top and goes down through the pen. It goes through these little gears. It gets heated up and it comes out an extrusion nozzle, and with the hot material onto a platform. Same in a 3D printer. It gets heated up, it comes through the extrusion nozzle, and it comes down and prints the object on the platform. So this is really important to show them so that they understand the similarities between them. And again, it lends itself to those competencies. It makes this real for them. It makes it, they make the connection between the two different situations and the two pieces of equipment. I also want to point out that fused deposition modeling and fused filament fabrication are two really common terms for this. It's a really common term to use, and you want to get that terminology into your students' head. You want them to use these terms. The FFF is the most appropriate term for us to use here because FDM is trademarked by Stratasys, I believe. So I tend to use FFF exclusively. So to do this activity, I created a template, and you see the template here. I think I can't see it on my desk right now, but what I did is I created a template for a lot of reasons. The main reason was because it serves as a platform, okay? And I put in some common geometries here. The circle is a very, very useful thing to give your students to have. And so I'm going to demonstrate how you're going to use that later. And then the grid helps you get the more precise geometric shapes and things that you want to do with the pen. And so the template comes in very, very handy. Let's see. So I'm going to launch into now. Yep. Going to stop sharing here. Close the share tray. Can you guys see my desktop now? My hand?
Yes.
Yeah.
Okay, good. All right, I'm going to turn on the pen. You can see here the red light is on. When it goes green, we're ready to print. So before I do that, while we're waiting for it to go green, first thing you want to do is get your template cut out, because we're going to make a couple of shapes. We're going to make a cube and we're going to make a sphere. And then we're going to take those shapes and we're going to, at the very end of the workshop, I challenge the participants to make something functional out of these shapes. And it's very interesting what they come up with, but we'll get to that at the very end. So the first thing that we want to do is we want to make a guide for our sphere. And so here's the sphere, right? It's this shape here, cut out. You cut out, and this is not all that easy to do, folks, but you have to cut out the center in the exact size, the exact diameter of a ping pong ball. So that's why I provide this, because we're going to use our ping pong ball as a mold, and we'll talk more about that later, to do our sphere. To do our cube, we're going to use our grid. But before we even start any of that, you want to teach extrusion. Temperature and speed control and extrusion. So what I do is I explain, I usually use the slow setting because it's just a lot easier for me. And what you want to do is you want to get them to start practicing just good old extrusion. So you can see it's coming out of the pen right now. You want them to do little blobs, right? Do a little blob and just kind of see. Just kind of see and lift it up, just kind of see. And then the other thing you want to do is you want to teach work in small areas and hold it perpendicular to your platform. So I hold it as good as I can, straight like this. And what I'm going to do is I'm going to draw a K for Kim. So I turn it on. And I'm doing a block letter. You can actually have them draw this on the template before they actually draw it with a pencil, before they actually draw it here with the pen. I'm just kind of freehanding it for the sake of time. So you have them do that, and then you explain. You kind of see it here. Then you explain, you just made your first wireframe. And wireframes are used in a lot of situations. Every 2D object starts with a wireframe. And what it does is it creates a boundary for you, because when you come in and you start filling in, got it on again. You start filling in, it acts as a guide. And there's a lot of different ways you can fill this in. You can do what I'm doing right here. It's called an inline fill. You can do it that way, or you can come down to one part of your wireframe and you can just start going back and forth like that. So in a lot of ways, this emulates, and what we're doing here really is emulating processes with the pen that actually happen with the 3D printer. So what I'm doing here is I'm emulating with the infill, I'm emulating doing a solid object, right? So we form our perimeter and then we do our infill and boom, we're done. The other thing that you need to do is you need to be able to get your piece off. So I'm going to go right here and show you how with the spatula, sometimes you need to help it a little bit. Here we go. But that's what you use the spatula for, is to get your piece off of your platform. And there we go. Okay, the other thing you can talk about when you're doing this with the pen, you can talk about line width and height. Extrusion, when you're extruding, this is the process that you're going through with the pen. Extrusion just means pushing filament out of the nozzle. That's the definition of extrusion in this case. I know we know extrusion, other definitions and things, but that's the definition in this case. And you can talk about consistent pressure and consistent streaming of the material. And that's what you want with a 3D printer too. You want to be able to set your equipment up so that you're getting the same thing. So with the pen, you can explain, you want consistent pressure and you want consistent streaming. And what I do after we do our initials with the wireframe and the infill, I ask the students, so what does your line look like? Is it flat and transparent, or is it bumpy, lumpy? You know, and you get different answers to that. So mine was kind of flat and transparent. That means I had too much pressure. So you might want to let up on the pressure a little bit. If it was lumpy, bumpy, you didn't have enough pressure. So you can go walk through the different things with them about that. When you see things like that, when you're 3D printing, you know you have to do some adjustment. Eric was talking about engineering analysis. You know, you can analyze your prints even with a 3D pen, and you can talk about those things. So that's important. And then the material, again, the heat, you can touch it right away. I don't have a problem touching my plastic right away, but you don't want to touch the nozzle. And so that can burn you. So you want to be sure that they understand that and that they can work with this material in a lot of different ways. Okay, so using the 3D pen to do a cube. I'm going to show you how to start out, but then I'm going to go to video for this because it's a lot easier on me. But I'm just going to start out here. What you want to do is we want to make 3 by 3 squares. There's 1/2 inch squares here. So you want to start here with a blob, and you want to go around your template here, following your lines, and then go up. And look at my hand. I'm staying as perpendicular as I can, as steady as I can. It's not always easy. My arm is staying tight on my desktop. I use my desktop a lot. And then I'm going to go here and I'm going to infill. And I'm doing a diagonal infill. And at this point, I ask people, why would I want to do a diagonal infill? If they've studied 3D printing a little bit and they've talked about this, supposedly, I mean, there's different opinions on this, but supposedly the diagonal infill is stronger as opposed to an inline. I'll show you inline. Here's an inline infill, just following the perimeter around. So there's a bunch of different ways you can do this, and you can show them. And again, you can show them how to get it off. Sometimes you got to let it sit a little while. I find, oh, there we go. I find it pops off pretty easy, pretty fast. So that's a partial example of the first side of a cube. So I'm going to open my share tray again, and I'm going to go to my video and show you the video. You're going to like this. The reason I did video is because a lot of things can go wrong. when you're teaching this stuff. And so doing video and having the video available instead of like doing it live like I was, that just saved me a lot of time and headache. If my pen would have failed, if something would have gone wrong, if something happened and I couldn't show the process, I couldn't finish the workshop. So that's why I made the video. So I'm going to show you the complete process. Here we go, kids. Complete process of doing this cube. So there I'm explaining again the 3x3 space that you need to work in. And I start doing I can actually speed this up just a little bit. Getting the blob like I showed you, I'm going around down the one side and up. And this is called wire framing. I think I'm going to have to, let's see, got 9:30, right? Where are we at? Ooh. All right, I'm going to speed up the video. And then I'm going to show you joining. When you join the object, it's really easy to tack inside. What we did in the workshop is we created 4 equal sized sides of the cube. And then we had to adjust and we had to adjust our template, and we had to make 2 of the sides different. We had to make them so that they would fit onto the sides that we're joining here. So if you notice what happens here, because we're putting the sides together right up against this one that's a 3x3 square, that's going to make this length for this side over here a little bit longer, a little bit shorter. So we had to adjust that. And you can talk about, when you talk about this with your students, you talk about line width. Line width takes up space. So if you're joining something like this and you're overlapping like I am here, you have to take that into account. You have to make sure that you have the pieces that fit. Okay, I'm going to speed it up here. So there I'm kind of showing that. I'm showing that line width is important. And there I'm showing how you can adjust your template so that you can make that happen. You can make sure that you're adjusting by the line width. And it's funny, I discovered in doing this workshop that 3-point line width on my template was almost exactly what I needed to adjust for when I was doing this. So you learn things when you put activities like this together. Okay, I'm going to speed it up here. All right, so this is showing how the sphere is done. Basically, doing the sphere is a little tricky. You got to handle it carefully, but you can see I'm holding it perpendicularly again against the ping pong ball, and you go around. And with this, you can talk to your students about molds. You know, a lot of times what you make in your 3D printing shop, it is a combination of processes. So the old process of using a mold, you know, you can talk about that here. But basically, you just do the line going around your ping pong ball. And I did it really sloppy for a reason, because getting these things off of the ping pong ball is a challenge. And I use something called a FID to do that. And you're going to see the FID come up here in a minute. The FID is a really handy tool. It's used in a lot of different applications. There's the FID. It's used in a lot of different applications. It's painful to watch this. So I told my workshop participants when we did this virtually that we were just going to leave it on the ping pong ball because I didn't want them to stab themselves and get in trouble with this. So I just kind of let it go, right? And so we just made our ping pong ball the center of our sphere. I got to speed through here. Almost done. The last thing that I showed them how to do is to use the geometries, the template to create some geometries. So what we did is we created a bunch of equilateral triangles to make a snowflake. And we actually did 8 of them all together. And the way that the template works is really cool because you can teach coordinates. There's a coordinate right here. We counted up 10. And we got our first triangle going, and then we used our ruler to do 4 centimeter long sides for each of our equilateral triangles. And then this is really cool. Gonna show you how, like right there, same thing. You can put a dot there and do 2 4 centimeter sides. And in all, we got 8 equilateral triangles to make our snowflake design. And there it is. And then we printed that out. And the other thing that I taught here with the snowflake is, oh, I might have messed up the video. The other thing I taught with the snowflake is repeatable shapes. If you can use repeatable shapes in your design, it makes it stronger. That's true of all 3D objects. As long as you can do that, it saves time and it makes a stronger product. The other thing that you can teach with the snowflake is we get into some of the terminology, and some of that terminology you can just walk them through with this. And one of the terms, I think you've all heard the STL acronym. If you tell them about the STL acronym while you're doing this activity, the T stands for tessellization. Tessellization is just laying a design down in triangles. Well, what do you do when you're meshing with a 3D printer, right? You're laying down your design in triangles. And for me, when I figured that out, when I was putting this workshop together, it's like, that was a big aha. And I bet if you do that with your students, they'll never forget what that T stands for. And so that's kind of a significant learning there. See, we did joining, we did scaffolding. Okay. All right, I think that's pretty much all I'm going to show you. Yeah, that's all I'm going to show you of the video. Let me get back here. Okay. Stop sharing. Stop sharing. Have we done that? So does everybody see me now? And you can still see my desktop, I hope.
Yes. Yep. Absolutely. Yes. We see, and it was amazing. You know, you showed us how it works, and I think this is a great hands-on experience for our teachers and for our students. So
yeah, let me just show you. Yeah, let me show you the final product. What they did was they put together a cube, right? Just a simple cube, and they put together a simple sphere. They had to join the sides of the cube, and they had to join the sphere. And then I challenged them, and and they also did the snowflake. This is the example, the snowflake. And then I challenged them to do to use these shapes to make a movable part, a functional part. So they created a ball and socket. This is my example, my prototype. And I gave them parameters to follow for their design. So the ball and socket, they had to pay attention to tolerances around the piece that holds the ball in. The ball could not fall out. It had to stay in, you know. And with the gear, they had to use the triangle shapes to create a gear with a hole in the center. And so that's all I told them. I gave them their parameters for the final project, and they just ran away with it, and they did a great job. All right.
Perfect. Thank you so much, Kim.
Hard to do a 3-hour workshop in 30 minutes.
Yes, it was amazing. Yes, fast and efficient. Great. So we have our high school teachers that here and our students. Look at their faces. Thank you. Thank you so much, Mr. Jared Groth Olson, Mr. Ryan Brill, and Mr. Garrett Winslow for accepting to share your educational experience at here. We would love to hear your success story.
All right. First of all, I guess I just want to make sure that you can hear us.
Yes, yes, we hear you.
Awesome. I don't know, Ryan, I just want to talk about that stuff.
Sure. All right, so I'm Ryan Brill. I can't see where we're on the screen. There we are. So we at River Falls High School, we put in this STEM lab. It was a district funded through a referendum. It was implemented last year, and we have been running it through COVID and everything like that a little bit. Due to some of the constraints that we had when we were putting in this fab lab, we weren't able to get the all the top of the line 3D printers that we wanted. We were hoping for Prusa or to get more into the industrial style 3D printers to be able to bring on into or to train our students into industry. However, due to some constraints and stuff like that, we ended up having to go with our budget ones, and it actually turned out to be kind of a huge benefit for us. So we've got 8 Creality FDMs, 2 of the CR10s, or sorry, 4 of the CR10s and 4 of the Ender 3 V2s. We also have a couple of the Lulzbot 3D printers as well. And when we first started putting these in, these students, when we would train our students in on the 3D printing, they would say, hey, you know, can I get these at home? And then we've had, was it like 5 or 6 students get our Creality printers at home. And then we've also had, it's either 2 or 3 local businesses get into the 3D printing for some of their products there as well. And what's really nice for the students and for our community is that they're able to come in if they have any problems with their printer or troubleshoot or anything like that. They're able to come in and ask us and see what's happening. And when we have the exact same printers in the schools as what they have at home, we're able to help out our community and our local businesses as well. One kind of cool thing, well, it wasn't the greatest with COVID, but when we had the face shields and the mask shortage and everything right at the beginning, we gathered all of our makers and stuff like that in the area that had these 3D printers, and we ended up producing, it was like 1,100 or 1,200 face shields that were distributed between the 2 counties that we serve. And then finally, one thing that we're really getting into is the SLA printing. So while some students were in quarantine, they went home, they learned how to do Blender and some mesh modeling and started making minifigures and stuff like that, and came in and said, hey, can we start doing the SLA printing? And again, because that price point is lower, that for the Creality, it's the SL 2000R, real goofy name. We're able to start getting into that in the applications that we're bringing art students and other types of students into our STEM lab, because we have the lower bar of access to our different types of 3D printers. So it's been a really cool journey to be able to not only help our business and our community members and stuff like that with the support of the 3D printers that we have, but also be able to come into different avenues such as art forms and minifigures and stuff like that in the art department, and then expose everybody else to 3D printing and that sort of thing. So yeah, I don't know.
No, yeah. So what we're able to do is take those that fabrication process and apply it to or implement it into our classrooms as well. First, I was really excited when Mahmoud and Garrett reached out and said, "Hey, we've got this competition. Do you want to be a part of it?" And so I've got this applied engineering class, and it's like, "Yeah, let's give it a try and see how it goes." The first big thing was trying to figure out how to implement it, how to best implement it into the classroom. And based on the class size that we have, it really worked out well just to make two different groups of 6. And we assigned a role to each of those students of 6. Actually, while I'm talking, if we want to get the one group here, so come on up and show your lovely face. There we go. Yeah, I get the whole group. All right. So from our group, basically we have a CAD person to bring in that CAD side of things. We have a fabricator who's kind of taking the CAD and running with it with the 3D printers or other types of additive manufacturing that has to happen with that. We've got a documenter, and the documenter's role is just kind of making sure everything is documented. What else we have? We've got a programmer, so we do have a Vex Cortex that runs the program for the machine. So we have a programmer specialized for that. And then lastly, there was a step that I don't think any of us have really gone through before, and that was using a cell phone application. So designing a cell phone application that actually kickstarts the Cortex, so connects through Bluetooth and gets that going. So this has been a really great learning process of just figuring out what are all the different steps involved, and just kind of learning how those steps work and what has to happen to make it happen. So here's our one group. And this design competition was basically they need to make a machine that will put the cap onto a film canister. So I think Logan's going to tell us kind of big problem they had, or kind of any stumbling blocks and kind of what they did to fix that.
Yeah, so I'm Logan, and for our machining project, one of our biggest challenges was getting our hammer to a final design and making sure that it was going to hammer in the cap every single time. At first, we started off with our hammer having 2 very long bars connected to its stationary holder to hold it in place. And it worked at first, even though it had a mechanical advantage at 1 just due to its sheer force of weight. And then we ended up changing the design to move it closer. And then we also ended up having our bars that connect it together to be parallel, so there's not some resistance happening in between it, so that way the hammering process would go smoothly. And then eventually we ended up making the bars smaller and moving it even closer to make it a more precise hammer down on the cap to the bottle.
Awesome. Thanks, Logan. All right, so we're going to grab our other group. Another group. So then from our other group, what was nice about this project and the competition is that the constraints were broad enough that still allowed the students to be able to really take their creativity and take their own touch to it and come to those decisions on what is the machine going to look like. So it wasn't so specific that everything was the same. There were aspects to it that each group saw what the other group was doing. Is like, oh, that's a good idea. I like that. I'm gonna steal that. Which that's kind of corporate life in it as it is anyway. So this group, they kind of went with a different design where we've got a tube. Yeah. So they've got a tube and a piston as opposed to just that 4-bar that comes down and caps the machine. But I think Owen's going to tell us just kind of a little bit overview of theirs.
Hi, I'm Owen. So the biggest problem that we had was figuring out the lengths for the bars of our 4-bar. So we used a simulation in CAD as well as just a 4-bar simulation to get the lengths a little more dialed in, so that we were getting the desired amount of force to the bottle and the cap, so it was capping correctly. Yeah, that was pretty much the biggest thing we had. And sorting out the 3D printing was a struggle at first, but after we got a little more familiar with the printers and CAD, it went pretty well.
Thank you, Owen. All right. Yeah, you guys can have a seat. Thank you. So I guess overall, just the overview of the entire process and the project. We could have done it with just pre-manufactured VEX pieces and parts that bolt and screw together, but I think the additive manufacturing aspect of it, of having the 3D printers, really brings out the options. And so, like with the tubes and with the end effectors and the pieces where I need a tube that's this big, or I need a piece that's just a little bit smaller than the one I have, we're able to very quickly, within one-day turnaround. Basically CAD it up, change the CAD design, and then get it printed and then put it on the next day. And what was nice with that was how many tube versions of the tube did we have? Six, right. So from the tubes, we ended up having 6 different versions or 6 iterations of the tube. So the tube would go on, they would find out, hey, that hole's too small, we got to move that a little bit bigger. So if we didn't have this quick turnaround for the manufacturing of the fabrication process, it would have been a lot more difficult to be successful with this project. So I think it's about all we got. I don't know if Garrett's up next.
Perfect. You combined different technologies integrated in one platform using app, using CAD, additive manufacturing, and other processes that you have there. Congratulations. I would like to touch those mechanisms in our summer workshop in August to see how they are working and how they are, doing the job. Thank you so much. Appreciate that.
Hopefully we won't break them by then.
Thanks to our industry member, Mr. Pills, invited our high school U to their facility in the Hudson area. So that's a good news for all of us. Thank you, Steve. So if there's any questions for our diligent high school teachers and students, please share it here. We would like to hear and answer. Okay. Seems that everyone is happy with what you shared. Comprehensive presentation. So we just received one question from Kim. Yes, she shared a resource for their modules. So the nice thing about Microsoft Teams is this: you can save all those URL links and use it later. So you are part of this chat area, and then you can use all our links and resources. Thank you so much, Jared. Thank you so much, Ryan. It was perfect. So Mr. Wenzel is working on a big idea and initiatives. So I would appreciate if he can share his idea with us today.
Hi, Mahmoud, and everyone else here. I appreciate all the sessions so far. I learned a lot today. It's been pretty awesome. So I'm Garrett Wenzel. I'm the technology and engineering teacher at St. Croix Central High School, and that's in St. Croix County, Wisconsin. I just want to highlight that because I know we have some people from kind of all over, and as Mahmoud said, we have some international people joining us as well, but I think they may have left now. But just to give you some perspective, St. Croix Central High School is about a half hour away from the Twin Cities of Minneapolis and St. Paul. We have, we're close enough, like a half hour drive to, 3M headquarters or Anderson Window, or there's a lot of, very big manufacturers in the area. And just really within the county as well of St. Croix County, we have a very strong, I would say, machining and plastics industry for injection molding. So my idea, and just in case you're worried, this is my co-presenter, Oakley here. I'm actually on my paternity leave right now and just hanging out with him. But let me present my screen here. Can everyone see my screen?
Yes, Garrett, we see that. Yeah.
Okay, good. So it is weird because I can't really see anybody else either. So basically, just like a lot of other technology and engineering teachers, as we kind of saw with what Ryan and Jared presented, that they wanted the nice fancy equipment, but they really couldn't afford it. And this is something I constantly run into. Is I want my students to have a good experience. I want them to learn about equipment they'll find in industry, or kind of start preparing them for tech college or a university. But I find myself writing a ton of grants. So even like earlier this year, I had to write, a $3,000 grant, actually it's $2,000 grant, just to get a desktop injection molder. And to a lot of businesses, that doesn't seem like a big expense, but a one-person department at a high school, that is. So it's something. It's this constant battle of funding, and I hate how that really has to be right now. I feel like we need to really start sharing resources a little bit more, and now, to connect this to one of the other symposiums that Mahmood has hosted, Kathy Dallas from SME, the Society of Manufacturing Engineers, did a presentation, and she mentioned something how the SME has prime schools. And I've never heard of that, so it really intrigued me. So I started digging a little bit, and I contacted Kathy. And basically, what they do for the SME is you kind of have to get selected as a high school. They'll come into the area. They'll actually meet with local manufacturers to see what are the jobs that are in demand, what jobs are going unfilled right now, and then they'll figure that out. They'll come back to the high school. They'll say, okay, these are the jobs we need to prepare students for, because this is what's really needed in your area. So I think. It was really innovative, and it really sparked a lot of my interest, because it's like, wow, this is something that's not like a canned curriculum. It's very new. And with being a smaller school, I felt like, yes, this sounds awesome, but really I see it being a better fit for St. Croix County. Because we have a lot of, smaller school districts that could benefit from this. So that way teachers don't have to, if we had one facility that has all this really expensive, fancy equipment that, students have access to, it's going to be a benefit to everyone, and teachers can get back to more so teaching rather than worrying about funding and everything else. So my proposal, and this is my big idea, that it kind of relates to additive manufacturing and, what we've been talking about today, but also more traditional as well. But a space in St. Croix County that all school districts in the county could send students to, say their junior or senior year. They'll get to, experience some more advanced classes in manufacturing. And anything related to manufacturing. They'll have access to, expensive equipment, as far as, looking at a Haas CNC mill, that's a $30,000 piece of equipment. That's tough for a school to get. It takes a lot of funding. So, it'd be nice if we could get, a couple of those that they have access to. Our plan will be to partner with our local technical colleges, the WITC, Wisconsin Indiana Technical College, and Chippewa Valley Technical College. And make sure that they have some stake in this as well, that, maybe we just do some transcripted credits, maybe we have it open to them so those colleges have access as well. So these high schoolers are getting the college credits and industry certifications along with it. And I think this forms a much stronger partnership between schools. It forms a great partnership between industry. And really it could, ultimately be open for the community as well. It's kind of that whole Fab Lab idea, but, bringing it maybe even to the more advanced next level. So I think that, I've reached out to some of the local manufacturers in the area, and they've really said that, yes, this is a need because they can't find anyone. As I drive around the county, I go by, some of these plastic injection molding companies, and they're offering $3,000 sign-on bonuses because they can't find anyone. Going on a tour last year, of, again, a plastics company. They couldn't find an industrial technician to maintain their equipment, and they were paying very good. They just couldn't find anybody. And I just think that, we are seeing this large disconnect between high schools and what's happening in the real industry. And basically it's coming back to that, well, we just don't have the funding. We don't have, access to some of this more advanced manufacturing equipment that students really should be learning to prepare them for their futures. So that's my little rant. Hopefully it made sense. And if anybody has, let me stop. How do I go back here and stop sharing? Okay, I think I'm back.
Great idea.
So again, I want it to be a big community supported thing. We need to invest in younger people getting into manufacturing because there's a ton of different avenues that they can get into. I'm super excited about it. It's just very early on. It's very much an initial idea right now. There's a ton of logistics that have to go into it. But I definitely see the potential, and from the manufacturers that I've already reached out to, they're very supportive of this kind of idea that we feel that we need a facility like this.
Absolutely. Thank you for sharing this with us, and we need that facility. And I think if different sectors work together, we can have a bigger one with more equipment to support our community. If there is any questions for Garrett, this is a good time to share and ask him.
I know I'm hitting the end, so I'm sure everyone's filling out their surveys right now.
You know, today in the morning, I kind of become emotional because you are on paternity leave, and Oakley and you presenting a tier to us. So this is amazing. So thank you so much, Garrett. This is highly valuable.
Oh, absolutely. Thank you for having me. I've gained so much out of these symposiums. I really appreciate it.
Hold that baby up again. So cute. A ginger.
Yeah.
So cute.
So
I was gonna say too, Hans is on this. Hans, were you planning on doing something, having a lab available?
We do, yes. We have a fab lab. We're doing a remodel on it this summer, and any high school can submit jobs to us to print on our 3D printers that we have there. So we have an online form available, and if anybody's interested in that, you can contact me or Mahmood, and we'll enable you to do that.
Yeah. There's another online resource. I can't think of the name of it right now, but I'll shoot it over to Mahmood. And I mean, you don't have to have the printer physically in your school. You can do a lot of things free with these online services. So I think that might help you out a little bit.
Absolutely.
we are approaching to the end of today's event. And thank you so much for your support, for attending. You put time, and we appreciate that. I think Hans has shared links for surveys. We appreciate if you could fill out those. And thank you again. Have a wonderful day.
Thanks.
Thank you, everyone.
Thank you, everybody.
Thank you.
Thanks, Kyle.